Okay, good morning. Welcome to
KidMath number 109.
KidMath number 109. So for the last few days, it started with KidMath106, we've been finding a formula for the Fibonacci numbers. And we found it, we wrote it down yesterday. The nth Fibonacci number is 1 over the square root of 5 times 1 plus the square root of 5 over 2 to the nth power minus 1 minus square root of 5 over 2 to the nth power. And so just writing out the Fibonacci numbers, I call Fibonacci number 0, 0, and Fibonacci number 1, 1. And then you just add the last two together to get the next one. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. So we keep going. Now, it's kind of hard to believe that this formula with a bunch of square root of 5s actually replicates this series of numbers, or this sequence of numbers. Right? It is pretty hard to believe. And the amazing thing about this formula, and I'm going to show you two amazing things about it actually, but one amazing thing is if I want to know the 50th Fibonacci number, normally I've got to calculate all of them because to get the 50th, I got to get the 49th and 48th, and to get the 48th, I got to get the 47th and 46th, and so I got to just go all the way backwards. This formula here allows you to get it right away.
But something to do with the 50th power is going to be a little large.
Yeah. So it's not obviously easier if you just have pencil and paper, but if you have
Wolfram Alpha.
If you have Wolfram Alpha laying around, then you can do it, and I'm going to show that to you right now. Okay. Okay. So here we are over at a computer looking at Wolfram Alpha, and so we can see I'm trying n equals 2 for our formula, and I have 1 divided by the square root of 5. 1 times 1 plus square root of 5 over 2 to the nth minus 1 minus square root of 5 over 2 to the nth, and you can see I get 1. And remember, the way I was numbering the Fibonacci numbers, and you can look over there on the board if you want, our second term was 1. Remember, we started 0, 1, 1. And I can go to higher terms, like the sixth term, for example, was 8, so hopefully this is going to be 8. There it is. What came after 8?
It was 13 after.
13, so let's just try it to the 7th power. 13. It's pretty incredible, right?
Yeah.
So so there we go, and then I think we said about the 50th power. So let's just see what the 50th Fibonacci number is. And Wolfram Alpha can compute this really fast. There we go, 12,586,269,025. And the other neat thing about this, just so you know for fun, the square root of 5 is about 2.2.
Yeah.
1 minus the square root of 5 would be minus 1.2, and when I divide it by 2 I get minus 0.6.
And that's a small number.
It's a small number. Think of it as being like minus a half, just approximately.
Alright.
When I start raising that to powers,
It gets smaller and
I
smaller.
get a fourth, minus an eighth, a 16th. It's negative, so it alternates back and forth. So it gets closer and closer to 0. So as we start doing things like to the 50th power, this piece of our term becomes very small, and in fact what becomes a very good approximation is just 1 plus the square root of 5 over 2 to the nth power divided by the square root of 5. Remember, and this is the golden ratio, right?
Yeah.
So I'm just going to round this. Round it to the nearest integer, and you'll see we should get for 50 we should get 12,586,269,025. 12,586,269,025, just like we thought. But even for smaller numbers, like the fourth Fibonacci, which should be 3.
3.
It still works. So even just the first term is a very good approximation of the Fibonacci numbers, and that's really cool, right?
Yeah.
That's really cool. This is a great application of the quadratic formula. Just general algebraic manipulation. And we find a formula for the Fibonacci numbers. It's really neat. And we're going to do one more thing on the Fibonacci numbers tomorrow, relating them to continued fractions.
Alright.
Okay? Alright, good job, sweetie. Good job today.